Hello children, welcome to aimsindia's online classes. In today's video, from physics subject, motion topic we are going to continue. So our today's concept is regarding scalars and vectors children. Let's discuss about scalars and vectors. So actually in our daily life, we will come across so many physical quantities. In our surroundings or in the natural world, we come across so many things. So we used to deal with time from the morning we got up from bed up to night. In so many situations, we will take the help of time. It is the time to go to school, or it is the first period, or it is lunch time. Like that, we will come across usage of time in so many situations. Or mass, while purchasing vegetables, we will make use of this mass quantity. Or weight. In general scenario, mass and weight are they will be used with similar meaning. But if we think them according to physics subject, if we treat them according to physics subject, there is a difference between them. But in general usage, two of them are used with the similar meaning. Or force. For moving any object, we make use of the quantity called force. Or electric charge. So in our household, whatever electric items are there, they will all operate with the help of electricity. So for that, monthly we have to pay some amount, that electric charge. Based upon the usage of electric charge, we have to pay the electricity bill. These are all physical quantities which we are familiar with. In our daily life, we are familiar with the terms like time, mass, weight, force, electric charge. With all these physical quantities, we are familiar. So we know that time passes. So day will be completed, again night will come, again next day will come. So time passes, and physical objects have mass. Some objects will be having light weight so that we can lift them easily. Some objects will be having heavy weight. So, and things will have weight due to gravity. So any object which is thrown into the air will fall back onto the ground because of the gravity. So we exert forces to open the door, walk along the street. For walking along the street also, we have to apply the force. And to kick ball, we have to apply the force. And we experience electric charge directly through static shocks in winter. So during winter season, from our clothes, we might have observed some kind of sparklings. So they are examples of static electric charges. Means without any contact with any other object, just by rubbing, they will produce electricity. So these are all the general things which we will come across in our daily life. So all these physical quantities in nature, we can divide them into two broad groups called vectors and scalars. So whatever physical quantities we observe in the nature or we observe in our daily life, we can group them into two categories. One is vector, another one is scalars. So what are scalars here? Scalars are physical quantities which have only a number value or size or magnitude. Suppose what is the time? What is the time means? Suppose, or what is the mass? 100 kg. What is the mass? 100 kg. In what direction? There is no need of specific direction while describing the quantity called mass, because it will be having only the numerical value. It will be having only the number value, which is called magnitude. So a scalar will tell you how much something there is, how much mass there is, or what is the time, or what is the length. like that. So here a scalar will tell us how much the size the object is having, or how much quantity the object is having. About that size and quantity, the scalars will describe. They will explain only the magnitude of the object or number value of the object. So a scalar, it's a physical quantity that has only magnitude. Magnitude means size. So for example, a person buys a tub of margarine, so which is labeled with a mass of 500 grams. So he is buying a tub of margarine which is labeled with a mass of 500 grams. So it's a scalar quantity. So to describe the object what he is buying, only this 500 grams is buying. Or if he is going to buy 2 kgs of mangoes, 2 kgs of mangoes. So how much size of mangoes he is going to buy means 2 kg. So only 2 kg is enough to describe what he is going to buy. So like this, mass, here mass is a scalar quantity. We need only a numerical value for describing it, to describe it. So whereas vectors means they are different compared to scalars, because vectors are the physical quantities which have both size and direction. A vector will tell how much of something there is and in which direction it is in. It will tell us about the size of the object and the direction of the object. It tells about both the things. So that's why it is called as a vector. So vector is a physical quantity that has both magnitude and direction. That has both magnitude and direction. So for example, a car is traveling east along a freeway at 100 km/h speed. So here a car is traveling. How it is traveling? Towards east direction. Towards east direction. To describe the motion of the car, we have to take the help of its direction. And with what speed it is traveling? 100 km/h. Here we are measuring the speed of the car. We are measuring the speed of the car, which is a quantity which depends on both direction and numerical value. It is traveling towards east direction. It is traveling with a speed of 100 km/h. So for describing the speed of car, we need both the terms. We need both the values, its direction and its size. So here, such type of quantities like speed, they are called vectors. They are called vectors. Or speed here, speed in particular direction, it is called as velocity. If the speed is in particular direction, if it is not curved path, if its direction is a fixed direction, then it is called as a velocity, which is a vector. So actually speed means in any direction it can travel. It don't have any particular direction. But if the same speed, if it is in particular direction, then it is called as a velocity vector. So the car is moving with 100 km/h. This is the magnitude. And car is going towards east direction. This is the direction. So these two quantities, the speed means magnitude of velocity and direction of car. Here speed is called magnitude of velocity and direction. Both together form a vector which is called velocity. Form a vector which is called velocity. Next one, examples of scalar quantities. So mass, it has only a value, it has no direction, it is a scalar. Electric charge, it has only a value, no direction, it is a scalar. How much electric charge is passing? How many coulombs of electric charge is passing? So it will be having only the magnitude. It is a scalar. So examples of vectors means force. Whenever we are applying force, in what direction we will apply force, the object will move in same direction. So while using the quantity force, it will be having both value and direction, both magnitude and direction. When you push or pull something with some strength or with some magnitude in a particular direction, the object will move in the same direction. So force is a vector. Or weight. Weight also will be having both value and direction. Both value and direction. Because any object on the earth will be having weight. Because if you take, for example, if you take our body will be having weight because of the earth's gravity, because of the earth attraction force. So earth attraction force is acting on our body in downward direction. That's why we are having weight. So here, weight means it is proportional to your mass. It is proportional to your mass and is always acts in the direction towards the center of earth. Weight will always act towards the center of earth. So it is a vector. So weight is a vector. So vector notation. So here vectors are different to scalars, children, and vectors they have their own notation, their own symbolic form. While representing the vector, we follow separate notation. So there are many ways of writing the symbol of vector. So generally vectors are shown by the symbols with an arrow pointing to the right above it. Suppose if force is a vector, it will be having one arrow above it pointing towards the right direction, such that arrow mark with line with arrow mark represents that it is a vector. That is one kind of representation of vector, or it is called vector notation. Suppose if F represents force, W represents weight, V represents velocity, which means all of them will be having both magnitude and direction. If you want both magnitude and direction, then we have to mention it with line and arrow mark in complete vector notation. Suppose if we need only the magnitude of vector but not direction, so then only line is enough. No need of arrow mark, because there is no need of specifying the direction. That's why we can only keep the line without arrow mark. So here F line with arrow mark, this F bar with arrow mark represents the force vector, but only F bar without arrow mark represents the magnitude of force vector. Okay. Or sometime magnitude of force vector means it will be kept in modulus symbol, which means we have to take only the magnitude of force vector. Next one, we have types of vectors. So in vectors we have so many types. So first type is like vectors or parallel vectors. So here don't get confused with the word vector, children. Vector means it's a physical quantity. Do you know we are all familiar with the word force? Force is a vector. Why force is a vector? Whenever we apply force, we have to apply in one particular direction and the object will move in particular direction. So that's why while describing the quantities like force, along with how much force we have applied, in what direction we have applied, that also we have to specify. These type of quantities are called vectors. Suppose if anybody asks for time, suppose if it is 1 o'clock, if it is 1 o'clock, in what direction? We cannot ask like that, because time is such type of quantity which never depends upon direction. In any direction, the time will be always at that particular time 1 o'clock only. So that's why, so whatever quantities we see in our surroundings, they are divided into two types, vectors and scalars. So now we are going to learn about types of vectors. In that, first type is like vectors or parallel vectors. So the vectors which are in the same direction. So this A vector is going in upward direction, and B vector also going towards upward direction, but A vector equal to 2 times of B vector. One vector may be bigger, one vector may be smaller. It doesn't bother, because they are in same direction. That's why we call them as like vectors and parallel vectors. They may be equal, they may be not equal. It doesn't matter. But as they are pointing towards the same direction, they are called like vectors or parallel vectors. Next, second type, unlike vectors, anti-parallel vectors. Means opposite vectors which are not parallel or which are not pointing in the same direction. Not pointing in same direction means pointing in opposite directions. Pointing in opposite directions, they are called unlike vectors or anti-parallel vectors. Next one, third type, we have co-initial vectors. Suppose here we have so many vectors. This A, B, C, D, like that we have so many vectors. A vector, B vector, C vector, D vectors. All vectors are pointing in different directions. But what is the similarity between them? They are all having the same initial point. Means the place from which they are originated, from which they started, is same. Means their origin is same. Their origin is same, or their initial point is same, or their initial point is common. So that's why they are called co-initial vectors or common initial vectors. Co-initial vectors means the vectors which have same initial point and origin are called co-initial vectors. Suppose if the vectors are coming from different points, different origins, but ultimately if they meet at single point, same point, means final point, or final point is called here terminal point. Final point is called terminal point, means the point where they are meeting or where they are stopped, terminal point. So as they have common terminal point, coming in different directions but meeting at one particular point, so then they are called coterminal vectors. Means vectors which have same terminal point or same terminus are called coterminal vectors. Next, negative vectors means the vectors whose magnitudes are equal. Means if the first vector is having 5 units length, second vector also, if it is having 5 units length, their lengths are same, their magnitudes are same. So they are called equal vectors. But along with equality, if their directions are mutually opposite, means if one is towards right, another one is towards left, if they are like that with equal magnitudes, then they are called negative vectors. Then they are called negative vectors. If first vector is A bar, second vector is B bar, then second vector can be represented as minus A bar, means opposite to the first one. Like that we can tell. Next one, about equal vectors. Means vectors which have same magnitude and direction. If their magnitudes are same, like 5 units, 5 units, if their directions are same, first one is traveling towards north, second one is traveling towards north, In such case, they are called equal vectors. In such case, they are called equal vectors. One minute, children. Okay, children. Next, we have about coplanar vectors. Means vectors acting in the same plane or parallel planes. If the vectors, they are acting in the same plane, though their magnitudes are different, though their directions are different, but they are acting in the same plane. So that's why they are called coplanar vectors. Coplanar vectors or collinear vectors means vectors which lie in the same straight line. Which lie in the same straight line. If they are acting on the same line, if A vector towards east direction and in the same on the same line, if B vector is acting in the west direction, as they are acting on the same line, they are called collinear vectors. Collinear vectors. Next, children, we have unit vector. Suppose we have a vector, a force vector, whose magnitude is 5 newtons and it is acting towards east direction. That is force vector. Suppose if force vector is 5 newtons due east. Due east means towards east. Towards east. Like that we have a force vector. For any vector, we can calculate its unit vector. If we can calculate its unit vector. Means for this force vector, if you want to calculate unit vector, F cap means unit vector of that particular force vector. So this is called unit vector of force vector. Means whose magnitude is unit, 1 unit. Whose magnitude is 1 unit. Whose magnitude is 1 unit. Suppose if A bar is the given vector, then unit vector in its direction is given by A cap, which is equal to complete vector by its magnitude. Means for calculating unit vector, we want to divide unit vector along with its magnitude and direction by, we have to divide the complete vector with its magnitude and direction by, we have to divide with its magnitude, modulus of F bar. So F bar means complete vector with magnitude and direction. Modulus of F bar means only magnitude, no direction. Means F newtons due east by 5 newtons due east by 5 newtons. So 5 newtons get cancelled. So what will remain? 1 newton towards east. 1 newton towards east direction will remain after this division. So 1 newton in east direction means the original vector is moving towards east direction. Its unit vector also moving towards east direction, but original vector magnitude is 5 units, but its unit vector magnitude is 1 unit. That is the difference. So unit vector means it will be same like the given vector, but given vector magnitude may be more than 1, but unit vector magnitude is always 1. Both the vectors direction is same. Both the vectors direction is same. So unit vector means we have to divide the complete vector with its magnitude and direction by only its magnitude. Then the resulting vector will have magnitude 1 unit in the same direction. That is called unit vector of that particular vector. So modulus of A bar are only A without bar and arrow mark is called magnitude of A bar, A vector. So, or if you want to, if we from this equation we can come to another conclusion. A bar original vector equal to its unit vector into its magnitude. Unit vector into its magnitude, if you multiply, then we will get the complete vector. So the unit vector is always parallel to the original vector. Always parallel to the original vector. Next one, we have zero vector. Zero vector means a vector of zero magnitude whose magnitude is zero is called zero vector, or it is also having another name called null vector. It is denoted by O bar. O bar means the vector starts from this point, this is the initial point, and ends at that point. That will be the terminal point. And it means initial point and terminal point of the vector coincide with one another, then it is called null vector or zero vector. So the direction of null vector is indefinite, indeterminate. We cannot determine the direction of the null vector as both the points coincide. Next one, we have about proper vector. Means vector whose magnitude is not equal to 0, which is having some other value other than 0, like 1, 2, 3, 4 units other than 0, it is called proper vector. It is called proper vector. Next one, position vector. Means a vector which originates at origin and terminates at some other point in the coordinate system, not at the origin. It is called position vector. Means in the coordinate system in xy axis, it originates at the origin, and another point will be at somewhere in the coordinate system. So then this length will tell, this measurement will tell position of that vector in the coordinate system. So that's why it is called as a position vector. Next one, planar vectors. Non-planar vectors means vectors acting in different planes. Different planes are called planar vectors. So it will be in molecules. You might be having every body in the universe is made up of atoms and molecules. So inside the molecules, in its valency. So okay, no need of this point, children. You can learn later. So vectors acting in different planes are called non-planar vectors. Okay, children, that's all for today. So remaining topics we can learn in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website aimstoday.in for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.